Kozangpo, a warm welcome to Bhutan e-learning program. I'm Sabina Kafle from Changangkha Middle Secondary School, and this is a mathematics lesson for Key Stage 4, that's for classes 9 and 10. And the topic for today's lesson is defining trigonometric ratios. In today's lesson, we'll focus on 4 key concepts. First, we'll learn to identify the hypotenuse, the adjacent side length, the opposite side length of a right triangle. Second, we'll learn to define primary trigonometric ratios and its inverse. Third, we'll use the Pythagorean theorem to solve right triangles and its applied problems. And finally, we'll calculate the angle from trigonometric ratios. Now, let us begin our lesson by asking a simple question to ourselves. What does trigonometry actually mean? Did you all think about the answer? Well, this word trigonometry is derived from a Greek word, trigonon, meaning triangles, and metron means measurement. So in simple words, trigonometry is the measurement of triangles. Basically, trigonometry is the study of right triangles and its relationship between angles and side lengths of a right triangle. Well, in mathematics, we have learned about different types of triangles, but trigonometry deals with one kind of triangle, and that is a right triangle or right-angled triangle. As we all know that a right triangle always includes one right angle that is usually marked with a small square right angle symbol for us to identify it. And the other 2 angles in a right triangle are acute angles. The side length that is opposite to the right triangle will always be the longest side of the triangle, that is called the hypotenuse. In any right triangle, the 2 legs or the 2 side lengths of the triangle are given special names with respect to each acute angle. The leg or the side length of the triangle that is opposite to the acute angle taken into consideration is called opposite side length, or we also call it as perpendicular. And the side length or the leg that is adjoined or next to the acute angle taken into consideration is called adjacent side length or base of the triangle. Now let us take this right triangle to help you all understand better as to how we name the side lengths of a right triangle. In this triangle, as I've explained earlier, the side length that is opposite to the right triangle will always be the hypotenuse, which is the longest side of the triangle. Now, if we consider angle y, with reference to angle y, the side length that is opposite to this acute angle is 8 centimeter, so 8 centimeter will be the opposite side length, and 9 centimeter will be the adjacent side length because this side length is adjoined or next to the acute angle. Let us now look into the next right triangle. It's exactly the same triangle. In this case, we'll consider the other acute angle, that is angle x. With reference to angle x, the side length 9 centimeter will be the opposite side length because that side length is opposite to the acute angle that's been taken into consideration. And 8 centimeter will be the adjacent side length. So from these explanations, I hope you all are clear that 8 centimeter and 9 centimeter can be either the adjacent side length or the opposite side length based on the acute angle taken into consideration. Let us now move on to trigonometric ratios. The ratio of the side length in any right triangle has special names according to the acute angle when considered. Let us take this right triangle. With reference to angle x, the opposite side length is 4 centimeter, the adjacent side length is 3 centimeter, and the longest side obviously is the hypotenuse, which is 5 centimeter. For angle x in the triangle, the special ratios are sine x, cos x, and tan x, and the ratios are pronounced as sine of x, cosine of x, and tangent of x. For the first trigonometric ratio sine x, the formula is opposite divided by hypotenuse. The opposite side length is 4 and the hypotenuse is 5. So the sine ratio becomes 4 over 5, which equals 0.8. Moving on to the next trigonometric ratio, cos x, the formula is given by adjacent divided by hypotenuse. We substitute adjacent by 3 and hypotenuse by 5. So when we divide 3 over 5, we get 0.6. The third trigonometric ratio is tan of x, and the formula to calculate tan of x is opposite divided by adjacent. So we divide 4 by 3, that equals 1.33. Let us now take the same right triangle and calculate the primary trigonometric ratios. But this time, the acute angle that we take into consideration will be the other acute angle, that is angle y. With reference to angle y, our adjacent side length will be 4 centimeter, our opposite side length is 3 centimeter, and the hypotenuse is 5 centimeter. So sine of angle y, the formula is the same, that is opposite divided by hypotenuse. Upon substitution, we get 3 over 5, that equals 0.6. Cos of y, given by the formula adjacent divided by hypotenuse, that equals 4 over 5, which equals 0.8. And tan of y, given by the formula opposite divided by adjacent, that equals 3 over 4, which equals 0.75. From these two examples, it's very obvious that though the triangles are same, the trigonometric ratio results to different values depending upon the acute angle taken into consideration. These three ratios are called primary trigonometric ratios or trig ratios, and these ratios only apply to acute angles in a right triangle. Mathematicians have defined three other trigonometric ratios based on the primary trigonometric ratio, and each one is the reciprocal of the primary trigonometric ratio. Let us now look at what are these trigonometric ratios. So the fourth trigonometric ratio is secant of x or sec x, and the formula to calculate secant of x is the reciprocal of cos ratio. And in terms of side length of the triangle, secant of x is hypotenuse divided by adjacent. The fifth trigonometric ratio is called cosecant of x or cosec x, and the formula to calculate cosec x is the reciprocal of sin x. And in terms of side length of the right triangle, cosec x is hypotenuse divided by opposite. And the final trigonometric ratio is called cotangent or cot x. The formula to calculate cotangent or cot x is reciprocal of tan x. And in terms of side lengths of the triangle, it's given by adjacent divided by opposite side length. Let me solve an example for you all now. The question here is, for the given triangle, determine all the trigonometric ratios of angle x. As we all can see, in this given right triangle, with reference to angle x, the adjacent side length is 12 centimeter, the opposite side length is 5 centimeter, and the hypotenuse is 13 centimeter. So let us now calculate the first trigonometric ratio, that is sine of x, given by the formula opposite divided by hypotenuse. Since the opposite side length is 5 and the hypotenuse is 13, 5 will be divided by 13, that equals 0.38. Similarly, cos of x is given by the formula adjacent by hypotenuse, that equals 12 over 13, which results to 0.92. and tan of x given by the formula adjacent by opposite. Upon substitution, we get 5 over 12 that equals 0.42. So these are the three primary trigonometric ratios. Let's now move on to the fourth trigonometric ratio, that is cosec of x. As we all know that the formula to calculate cosec of x is 1 over sine of x. Since we have already calculated the value of sine of x, we substitute sine of x by 0.38. And the answer that we get for cosec x is 2.63. Moving on to secant of x, the formula is 1 over cos x. We have already calculated the value of cos x as 0.92. So, to calculate secant of x, 1 will be divided by 0.92, that equals 1.09. And the final trigonometric ratio, that is cot x, is given by the formula 1 over tan x. That equals to 1 over 0.42, which results to 2.38. Let us now move on to Pythagorean theorem. Pythagorean theorem describes an important geometric relationship between three sides of a right triangle. Let us look into what the Pythagorean theorem actually says. For a right triangle with adjacent side length A, opposite side length O, and hypotenuse H, the square of adjacent side length plus square of opposite side length will always be equal to the hypotenuse. That is, A square plus O square is equal to H square. Let us take this special example of a right triangle that will help us understand the Pythagorean theorem better. This right triangle is called a 3, 4, 5 triangle because its sides have relative lengths of 3, 4, and 5. And by relative lengths, I mean the units of length don't really matter. It can be in centimeter, in meters, inches, and so on. Starting with the adjacent side, that is 3 units long, what do we get if we square the side? Squaring 3 means multiplying 3 times 3, which equals 9. And the geometric equivalent of squaring something results in a square shape. As you can see in this square, it contains 9 unit squares. So the red area represents the value of A square in the Pythagorean theorem. Next, let's look at the opposite side length, that is 4 units long. Squaring 4 means multiplying 4 times 4, which equals 16. Again, the geometric equivalent of this is a square covering a total area of 16 units. So the blue area represents O square in the Pythagorean theorem. And finally, let's deal with the hypotenuse. It's 5 units long. Squaring 5 means multiplying 5 times 5, which equals 25. And the geometric equivalent is 5 by 5 square. That has an area of 25 units. So the green area represents H square in the Pythagorean theorem. Now, we can see how the arithmetic parts of the Pythagorean theorem are related to the geometric parts of the right triangle. Let's check to see if the Pythagorean theorem is actually true. On the arithmetic side, if we add up the amounts of A square and O square, they really do equal to S square because 9 plus 16 is equal to 25. And with a little rearrangement of unit squares, we can see that the area of the squares formed by the two legs really does equal the area of the square formed by the hypotenuse. Well, isn't that a cool theorem? It is, right? You all now must be wondering as to how and when do we use this Pythagoras theorem. As always, like many things in mathematics, the Pythagorean theorem is a useful tool that can help us use what we know to figure out what we don't know. Let us now look into this right triangle. With reference to angle C, the adjacent side length is 3 meters and the opposite side length is unknown, whereas the hypotenuse is given as 5 meters. This is exactly where we use the Pythagorean theorem to find out the measurement of the unknown side length. So using the Pythagorean theorem, a square plus o square is equal to h square. Since we know the adjacent side length, we substitute a by 3, and we also know the hypotenuse, that's 5, so we substitute hypotenuse h by 5. 3 square equals 9 and 5 square equals 25. So our equation now becomes 9 plus o square is equal to 25. But our aim is to calculate the unknown side length o, so we need to isolate o square. In order to do that, since 9 is added to o square, we need to subtract 9 on both sides of the equation to balance the equation, as a result of which we get o square upon simplification in the left-hand side, and in the right-hand side, 25 minus 9 equals 16. And to calculate the value of o now, we find out the square root of 16. So o equals to 4 meters. That is, the opposite side length of this right triangle is 4 meters. With this, I have a question for you all to try. The question is, determine the sine, cosine, and tangent of angle A using the given measurements. Next, we can also determine the value of angle x using any of the trigonometric ratios. For example, let us take sine of x equals to 0.8. In order to find the value of this angle x, we need to eliminate sine. And in order to do that, we apply inverse property. That is, we introduce sine inverse on both sides of the equation. Upon simplification, we get x in the left-hand side, whereas in the right-hand side, we have sine inverse of 0.8. We calculate the value of x using a scientific calculator to calculate sine inverse of 0.8. And finally, we get the value of x as 53 degrees. This is the next question for you all to try. And the question is, for which acute angle is each true? Part A, cos of x equals 0.6, and part B, tan of x is equal to 1.33. As we are now familiar with the trigonometric ratios as well as the Pythagorean theorem, let us now look at some of the special relations of trigonometry. There are some special relations based on the trigonometric ratios which are called the trigonometric identities. And these identities represent the relationship among the trig ratios. The first two relation involves relationship between sine and cosine of complementary angles, that is, angles that have a sum of 90 degrees. So the first relation is cos 90 minus x equals sine x. In order to understand this relationship better, let us look at this right triangle. As we can see that one of the acute angle given in this right triangle is x, which means the other acute angle will be 90 minus x because these two are complementary angles. Let us now look at the left-hand side of the equation, that is cos 90 minus x. The acute angle that has to be taken into consideration is 90 minus x. So with reference to this angle 90 minus x, 3 centimeter becomes the adjacent side length, 4 centimeter will be the opposite side length, and the hypotenuse will be 5 centimeter. To solve the left-hand side of the equation, we use the cos ratio. That is, cos of x, as we already know, is given by adjacent divided by hypotenuse. The adjacent is 3 and the hypotenuse is 5. So upon substitution, we get 3 over 5 in the left hand side. Let us now move on to the right hand side of the equation, that is sine of x. The angle that we need to take into consideration here is angle x. So with reference to angle x, 4 centimeter will be the adjacent side length, 3 centimeter becomes the opposite side length, and 5 centimeter the hypotenuse. The formula for sine ratio we already know is given by opposite divided by hypotenuse. Since the opposite of this triangle with reference to angle x is 3 and the hypotenuse is 5, we substitute 3 for opposite side length and 5 for hypotenuse. So we get 3 over 5 in the right hand side as well. Thus, left hand side of the equation equals right hand side of the equation. Therefore, this relation is proved. Let us now look at the second relation, that is sine 90 minus x equals cos x. To prove this relation, we will take the same right triangle. As we can see in the left hand side of the equation, it involves sine ratio. So we will use the formula for sine of x, that's given by opposite divided by hypotenuse. We already know that with reference to angle 90 minus x, our opposite side length is 4 centimeter and our hypotenuse is 5. So upon substitution, we get 4 over 5 in the left hand side of the equation. Let's move at the right hand side of the equation, that is cos of x. The formula for cos of x is given by adjacent divided by hypotenuse. With reference to angle x, the adjacent side length is 4 centimeter and the hypotenuse is 5 centimeter. So upon substitution in the cos ratio, we get 4 over 5 in the right hand side as well. Therefore, left hand side and right hand side of this equation are equal, that is 4 over 5. Hence, this relation is also proved. For the third relation, we use the Pythagorean theorem. As we all know that Pythagorean theorem says adjacent square plus opposite square is equal to hypotenuse square. Let us now divide both sides of this Pythagorean theorem by hypotenuse. Upon division, we get adjacent square divided by hypotenuse square plus opposite square divided by hypotenuse square, that equals to hypotenuse square divided by hypotenuse square. As we have already learned that adjacent divided by hypotenuse is nothing but the cos ratio. So here we get cos square x. Moving on to the next ratio, that is opposite divided by hypotenuse. This ratio, opposite by hypotenuse, is sine ratio. So upon simplification, this becomes sine square x. And the right hand side is hypotenuse square divided by hypotenuse square. It cancels and we get 1. So the third relation is cos square x plus sine square x is equal to 1. To prove this relation, let us take this right triangle. With reference to angle x, the adjacent side length is 4 centimeter and the opposite side length is 3 centimeters. Since we know that cos of x is given by the formula adjacent by hypotenuse, we substitute cos square x by adjacent by hypotenuse whole square. And the formula to calculate sine of x is opposite divided by hypotenuse. So we substitute sine square x by opposite divided by hypotenuse whole square equals to 1. From the diagram, since we already know the adjacent side length is 4 centimeters and the hypotenuse is 5, we substitute adjacent over hypotenuse by 4 over 5. We also know the opposite side length and hypotenuse. So we substitute the opposite side length by 3 and hypotenuse by 5. Upon simplification, we get 16 over 25 plus 9 over 25, that equals 1. Further simplifying, in the left-hand side, we get 25 over 25, that equals to 1. And thus, left-hand side equals to right-hand side. With this, I have some more questions for you all to try. Question number 1. Calculate the other 5 trigonometric ratios based on the given one. A. Cos of x equals to 0.4 and tan of x equals to 1.0. Question number 2. For angle x in the diagram below, use the given measurements to determine the secant, cosecant, and cotangent. Let us now quickly recapitulate what we just learned. In today's lesson, we learned to identify the hypotenuse, the adjacent side length, and the opposite side length of a triangle. We also learned to calculate the trigonometric ratios. Next, we learned to calculate the angle from the given trigonometric ratios. And finally, we learned to solve the special relations of trigonometry. With this, we come to the end of our lesson. Thank you for your attention. Take care and stay safe.